Okay, for revision paper 6 احنا we will start off um, ان احنا we will look quickly through the هنا. Okay, we'll look quickly through the syllabus. Okay, what are we required to actually know in paper 6? Okay, خلي بالكم most of the things, most of the points هنا and I will just go through quickly. Okay, I won't go through too much details into these points ليه علشان some of them you won't have in your exam. Some of them are for paper 5. خلي بالكم in this part practical assessment it talks about paper 5 and paper 6. احنا we are required to know paper 6 only بس we're not required to know anything about paper 5. خلاص ف paper 6 very quickly احنا okay يعني some مثلا for example okay planning an experiments. Okay, for example we know how to plan an experiment and you already know how to plan an experiment. Okay, but for planning experiment what do you need to do? You need to identify the independent and dependent variable again, and this independent and dependent variable. How do we identify the independent and dependent variables using ايه يا جماعه؟ using the اللي هي ايه sentence plan an experiment to كذا كذا كذا. خلاص this is how to identify which is the independent and which is the dependent variable. خلاص how. Okay, and what variables would be used, what variables would be controlled, what variables are to be changed. The only variable which would be changed is the independent variable. Other than that, all of the variables should be kept constant, and that's why we have to write down خلاص a range of values, the independent variable, and then the constants. Okay, the controlled variables, you have to write them down, and then you have to write down some of the apparatuses. Okay, or initially you have to write down هنا, for example, he told you the range of values, an appropriate number, and the range of values for the independent variable. The independent variable, that's why I always write down the independent variable first, the range of values, and then I write down some of the numbers that will be used for the independent variable. For example, if I'm saying the height, okay, I have to write down some values for the height: 10 centimeters, 20, 30, 40, 50 centimeters. That's the independent variable. That's the thing I will be changing. Other than that, all of the constants will be, or all of the other variables will be constant. Okay, you need to know what are the apparatuses that you will be using. ايه هي الاباريتسز. Okay, uh, for example, if I have an experiment, a pendulum. Okay, the pendulum. I'm measuring the period of the pendulum, whatever. Will I be using, for example, a thermometer? Okay, is that one of the apparatuses that I should write down in this experiment? Definitely not. Definitely not. I cannot write down a thermometer in an experiment using a pendulum, for example. Okay, some experiments can integrate two experiments into each other. ازاي? For example, I'm heating some water using a heater, okay? And this heater has an input voltage and a current, okay? I can measure the current, I can measure the voltage, I can measure the temperature, I can measure the volume, I can measure a lot of things. We have a lot of variables in this question. That's why this is one of the more famous questions. Measuring the temperature, okay, measuring the voltage, measuring the current. We have a lot of apparatuses. Okay, voltage, we need the voltmeter; the current, we need the ammeter; the temperature, we need the thermometer; the volume, we need the measuring cylinder. Okay, the time. This is one of the questions that will definitely ask you to write down the apparatus, and he will not give you the the stopwatch as an apparatus. He will ask you write down some of the apparatus is needed, and he will not write down the thermometer or the stopwatch. Okay, you always, usually, not always, okay, more than usually, you tend to forget writing down the stopwatch. It's a very crucial apparatus when it comes to the rate of cooling or rate of heating, when it comes to the pendulum, okay, when it comes to the power. Okay, it can be used in a lot of experiments. So do not forget to write down the stopwatch. Okay, this is as for the apparatus is used. The procedure, the method. What's the method? What should I do in the experiment? Okay, you have to write down that you will conduct 1, 2, 3, 4. Okay, you will take the reading from the given apparatuses. You'll take the reading from the apparatuses you will be using. For example, if you have some readings that depend on each other, for example, the resistance R equals V over I, you cannot say I will calculate the resistance and that's it. No, you have to say I will take the reading of the voltage from the voltmeter, and then I will take the reading of the current from the ammeter, and then I will measure or I will calculate the resistance R equals V over I. Okay, you can never say that you will take the resistance. That's it. You have to say how do you get the resistance? Okay, so this is the procedure. You will say how will you use? Okay, how will you use the apparatuses that you have? Okay, and then this is the procedure. Some precautions. Do I have to state precautions for every experiment? No. Okay. You don't, it's not a must for you to write down the precautions in every experiment. You can if you want to. If you know of any precautions, you can write them down. It's okay. But it's not a must. Okay. Identify any risks, safety precautions, okay? How to record, okay? How can I record the results, okay? How can I record the results? I usually record the results in a table, and that's why most of the questions, and again, I'm saying most of the questions, not all of the questions, okay, related to the planning and experiment, most of them tell you to write down a suitable table. This table, what do we write down in the table? Usually, okay, we have to have at least the independent variable and the dependent variable. For example, if I'm changing the mass, I want to measure the time taken. For example, I want to measure the period of the pendulum. Okay, so the independent variable was the mass. You have to write it down as a column heading, usually the first column heading, the mass slash grams. We do not use kilograms in the paper six. Why don't we use kilograms in paper six? It's too heavy. Kilograms is way too heavy in paper six. We're conducting experiments inside the lab. If you say 10 kilograms or a 20 or a 30 kilograms inside the lab, that's way too much. Way too much. Okay. Again, so if you have the table, the first column would be the mass. The second column could be the period slash seconds. This is the table. This is how you will record the results. Um, how will you record the results of an experiment? Describe how to process the results of an experiment. Again, using the conclusion, how will I come to a conclusion? We have 3 steps. We said you have to repeat and take average for each of the independent variables. Okay, for each variable or for each number in the range of values, you have to repeat and take average and then record the readings in the table. And then you have to compare the results. What do I mean by compare the results? You have to say, Wallahi, for example, whenever you increase the mass, the time we will measure how will the time change. Okay, whenever I increase the mass, how will the time change? Into you do not know if the time will change or not, so we'll just state, okay, that when I increase the mass, the time will change, and we will compare the results of how the time changes. Okay, can I write some of the constants in the table? Yes. Sometimes you can write some of the constants. You don't need to write all of the constants. No, you're not required to write all of the constants. If you'd like, you can write 1 or 2 of the constants in the table. That would be okay. But you have to. Okay, what you have to do is you have to write the independent and the dependent variable in the table. Okay, and then you come up with the conclusion. If for some reason he tells you to write down a or to plot a graph, usually we have 2 types of graphs. Okay, in the planning and experiment or in paper 6, we have 2 types of graphs. Either it's a directly proportional graph, or it's an inversely proportional graph, which would be drawn something like this. Okay, directly proportional graphs would be for things that you actually know would increase once you increase the independent variable. You know that the dependent variable would increase with it. For example, I need to measure the force whenever I increase the mass. Okay, the force required to push a car whenever you increase the mass of the car. So this would definitely be directly proportional. Whenever I increase the mass of the car, I am required to apply a much larger force. So this is directly proportional. Okay, this is definitely directly proportional. So for this question, he could ask you to draw a suitable graph. Okay, for this graph, you will write what you have to plot on the x-axis the independent variable, which would be, for example, the mass slash grams, and on the y-axis, you have to write the dependent variable, which would be force slash newtons. For example, okay, I'm just stating one example of directly proportional relationships. For an indirectly proportional relationship, an inversely proportional relationship, what would it be? For example, the rate of cooling. Okay, when do you draw it curved? For the rate of cooling, what do I mean by the rate of cooling? For example, if I leave it for a certain time, if I have some water and I leave this water for a certain time, then the temperature, okay, the temperature slash degrees Celsius would start to decrease in this way. This is an inversely proportional graph for the time slash temperature, especially for the rate of cooling. Okay, this is the rate of cooling. Any rate of cooling graph would be drawn like this. If you have, for example, not in the plan and experiment question, if you have, for example, a question 1 or 2, and you have some hot water, and then he has a table, and he tells you, please plot the table. Please plot these points on the graph. Most probably, the graph would be looking like this. Okay, even if he tells you draw a best fit line, even if he tells you draw a best fit line, for this graph, it would definitely be a curve. Okay. He doesn't have to clearly state that it is a curve. Not at all. Okay. He doesn't have to state clearly that it is a curve. If you have the points, okay, these points are looking something like this would be definitely a curve. It will never be a straight line. Okay. If you have an inversely proportional relationship, it would be drawn as a curve, a decreasing curve such as this one. Okay, again, back to the planning and experiment. He doesn't always ask us for graphs. He may tell you to draw a graph, draw a suitable graph. In that case, he will not tell you to draw a table. It's either a table or a graph. It's either or. He will never tell you to draw both. If he does, that's any okay. That could be an anomaly. If he does, okay, sure, I can draw a table. I can draw a graph. But in that case, you will know how to draw a graph. Um, can I say the type of graph that should be used? Yes, you should state the type of graph. No, but if he tells you to plot a graph, then you will have to draw a graph. Okay. And for the graph to be accurate, okay, for the graph to be accurate, you must write down the x-axis and the y-axis. You have to say what will be plotted on the x-axis and what will be plotted on the y-axis. You have to say on the x-axis, okay, this is the independent variable, and on the y-axis, the dependent variable. That's a must. That is a must. You have to label the axes. Yes, you must label the axes. And then, okay, if you have a graph, most probably it will be either directly proportional or inversely proportional. That's it. Okay. For example, directly proportional could be the force applied and the extension of a spring. That is a directly proportional graph. Okay. If I have many examples for the directly proportional relationships. Okay. That's for planning an experiment. Again, planning experiment, 7 marks. It's usually one of the easiest questions. Why? Because it's very systematic. Very systematic. You can very easily get, let's say, 6 out of 7. Okay. Very easy. You can score 6 out of 7. Why? Because it's very systematic. He clearly labels, or he clearly writes down what he needs in your answer. Okay, you will find the points 1, 2, 3, 4. Okay, not one, as points. You will have them as points. He will tell you he needs the apparatuses, he needs the controlled variables, he needs the method, he needs a conclusion, a table. Okay, so you will clearly write down all of these points while solving this question. Okay, it's one of the easier questions in your exam. Okay. Um, some of the observations or some of the measurements. Again, I'm just going through quickly through these points. I don't really care about the rest, okay? But I will go through them very, very quickly now, okay? How to take readings from the apparatuses, for example, taking the readings from an ammeter, a voltmeter, whether they are analog or digital, okay? Taking the readings from the measuring cylinder, from the bottom of the meniscus, okay? You have to make sure you're taking the reading perpendicularly, okay? How to take them with appropriate precision, okay, to the nearest half, okay. If there's half a scale, okay, then you'd say, for example, 95.5, 96.5, okay. You can write them down for the investigation. Someone's asking, you can write down in the investigation as a paragraph or as points. It's okay. You can write either as a paragraph or as points, okay. It is okay. um ماشي, you have a question?
هو أنا يا مستر سؤالي في paper 6 لكن مش في الإكسبيرمنت والجراف.
Hmm. طيب, can you text the question and I will inshallah I will answer it.
حاضر ماشي.
Okay. Um Okay, correct for zero errors. If you have zero errors, for example, if there was an error in the reading of the ammeter or the reading of the voltmeter or the balance, خلي بالكوا, the balance also has a zero error. Okay, the ruler. Okay, if you didn't start from zero, خلاص, I started from 1 or 2 centimeters, خلاص, يبقى I have to, you must correct for that error. Okay, make observations, estimates. Okay, take sufficient observations, measurements. Okay, repeat observations. Again, repeat and take average. This is a really important point. You have to repeat and take average. Okay. And I will talk about the experimental accuracy, inshallah. I will state it now. Record qualitative observations for tests. Again, for paper, for deep planning experiment, okay, there is a point that you have to say. While writing down the method, okay, while writing down the method, the safety precautions, whatever, okay, in the procedure, you must say that you will repeat, not repeat and take average, okay, you will repeat the experiment, okay, you have to say هنا, okay, repeat for all, okay, you have to say that, repeat for all of the range of values. For example, range of values. For example, if you have 5, 6 values in the range of values, you have different lengths, you have different masses, whatever. Okay, the independent variable. You have to repeat the procedure. You have to state it clearly. I know that intuitively you will do that. Okay, anyone who has an experiment will definitely do that. But you have to state it clearly in the procedure. You have to say that after you write down the procedure, repeat this method, okay, for all of the stated range of values. Repeat it for all of the masses, repeat it for all of the heights, repeat it for all of the widths, whatever you have for different colors. For example, if you're changing the color of the beaker, you have to repeat the experiment for all of these values. How can I? Okay, I'll answer that question as well. The graph and the gradient. Okay, I will do that. Record some observations again. شباب, when I'm talking about observations or some of the justification, okay, whenever he says justify, whenever he says justify, when he says justify your answer, you have to write down some of the numbers in the previous table. For example, if you have a table, okay, he says, Wallahi, what is happening to the rate of cooling? You'll have to say, Wallahi, the rate of cooling is decreasing. Okay, you know that the rate of cooling will be decreasing, but justify using some numbers, then you have to say that reason using numbers from the table. For example, in the first 90 seconds, it decreased a certain amount. Okay, in the final 90 seconds, it's decreased another amount. So that's why the rate of cooling has decreased. Initially, it decreased, let's say, 15 degrees Celsius. In the last 90 seconds, it only decreased 3 degrees Celsius. That's why the rate of cooling has definitely decreased. But whenever I say justify, okay, whenever I say justify, this question is usually worth 2 marks. The first is the reason, whether it increases or it decreases, or whatever happens to the question. And then when I say justify, you have to write down some numbers. Okay, you have to write down some numbers from the table from the previous question. If you measured, for example, the rate of cooling 1 and rate of cooling 2, rate of cooling for beaker A, rate of cooling for beaker B, you have to justify using the numbers that you have just calculated. Again, when I say rate of cooling, do not forget that the unit of the rate of cooling is degrees Celsius per second. This is the rate of cooling. Please do not forget the unit of rate of cooling. Okay. Which degree of accuracy? Yes, I will talk about the accuracy in a minute, inshallah. Type some of the experimental observations. Okay, we need to know how to use a calculator. Okay, a graph, plotting data graphically. Okay, best fit lines. Yes, best fit lines. In the best fit lines, يا شباب, the points don't have to align on the best fit line at all. Yani, not all of the points have to be on your best fit line. Actually, there are some graphs that can be drawn with no points at all on the line. You can draw a graph with no points at all on the graph, but usually, for to make life easier, usually you would have, let's say, 3 points on the line. One of them is above, one of them is below. You cannot have most of the points above, you cannot have most of the points below. Shabab, most of the points, okay, have to be very close to the line, if not on the line. 1 point could be above, 1 point could be below, which is definitely okay when I'm talking about the best fit straight lines. If I have a best fit curve, then most of the points will be on the curve aslan. Why? Because they're drawing this curve using freehand. Okay, you will not draw a curve using a okay, let me draw it here. Okay, if for example you had the points something like this, okay, these are my points. This would be a straight line. This would definitely be a straight line. How would it be a straight line? Let me draw a straight line now. Okay, this would be a straight line. How would it be a straight line? Oh, this would be a straight line. Something like this. You have 2 points above, 2 points below the line, and only 1 point on the line, which is okay. This is definitely okay. Okay. But again, what do I see about some people do something very, very, very wrong. Okay. If you had the graph and the points were going something like, let's say, كده. Okay. If you had the graph and your points were plotted something like this. Okay. This is a very rare graph, actually. Most probably you'll never have a graph like this. Okay. This is an increasing slope. Usually you don't have increasing slopes. We have usually decreasing slopes. But again, for this graph, what should I do? For this graph, what should I do? This has to be a curve. This has to be a curve. But what have I seen which is wrong? Okay. Some of you draw this. شباب, don't go like this. بعدين كده كده. This is definitely this is wrong. Definitely this is wrong. You have to draw one continuous line. You have to draw يا شباب one continuous line. One continuous line كده. This is how your curve would be. Okay, you could draw it even better. That's why we draw using a pencil. Okay, because you can erase it and then draw it again. This is my best fit curve for this question. For example, I'm just stating one example for a curve. Okay, this would be best fit. Yes, this is what we call a best fit line or curve. Okay, best fit line. For this question, if you ever think about drawing a straight line, it would definitely be wrong. Okay, if you have your points plotted like this and you even think about drawing a best fit straight line, it would be wrong. Okay, you have to draw them using a curve, one continuous line. Okay, don't connect the dots. Okay, well, you're not in KG1, you're not in preschool. Okay, do not connect the dots. We're not connecting one. لا. You have to just draw a curve, which would be a best fit curve. Okay, we have some questions. Okay, okay. Oh, okay. So we actually, yes, we determine if it is a straight line or a curve based on the points. Okay. You determine if it's a best fit line or a curve based on the points. Do you extend it? Okay, that's a really good question. Should you extend the line or not? If you want, you could extend the line. For example, this line, you could extend it all the way to the y-axis if you'd like. Okay, some questions. Okay, this is, for example, I, and then you'd find in I, he wants to find the gradient. Let's do the question for the gradient, and then I'll do another question. If he wants to find the gradient, how do I find the gradient? Okay, how do I find the gradient? The gradient is very easy. You have to use the triangle method. What do I mean by the triangle method? The line, no, it does not have to start from the origin at all. It does not have to be extended to the origin at all. How do I find the gradient? Using the triangle method. Oh, this is the triangle method. I have to connect the two furthest points, for example, okay? And it would be rise over run. Yes, thank you. It would be rise over run. Or in other terms, you can calculate, y2 minus y1 over x2 minus x1. But you must draw the line, okay? You must draw this triangle. If you do not draw the triangle, it would be wrong. Usually the gradient is worth 2 marks. You would lose one of these marks. If it's worth 1 mark, then you will lose the mark. Why? Because you must draw the triangle. You have to complete the triangle using two very far points. You cannot use, for example, these 2 points. If you use these two points, it would be wrong. If my points aren't on the line, oh, this is the case. If your points aren't on the line, it would be still okay. It would be still okay. ماشي. We have some questions. What's your question?
بس انا معلش عندي سؤال، هو ايه y2 minus y1 over x2 minus x؟
Slope. This is the slope. Okay. Slope. This is the gradient. This is the rise over run.
ايوه انا فاهم يعني، بس y2 y1 دول ايه؟
y2 هنا. This is y2, for example. This is y2 and this is y1. Okay. هنا this is x2 and this is x1. You'll find the values from the table usually. You could usually take the values from the table, but bear in mind that sometimes, in math, for example, okay, you are used to writing down the values of x and y, and the x usually is on the left hand side and the y is usually on the right hand side. Please make sure that your values of the x and y are from the given or from the graph. It would be easier to take them from the graph. Why? Because most of the times he does not give you the y-axis on the right hand side and he does not have the x-axis on the left hand side. So please take care while plotting or while calculating the gradient. Okay. Okay. The points. Yes, you can take the points from the table. You can take the points from the table. You can take the points from the table, but again, you still have to draw the you have to draw the triangle. Okay. What's your question?
طب يا مستر، في السؤال بتاع مثلا التايم والتمبريتشر لو هو جايبها لي في تيبل، انا امتى بعرف احط تايم ولا تمبريتشر على اكس واي؟
He will tell you. Okay. He will tell you, plot the time slash seconds on the x-axis and plot the temperature slash degrees Celsius on the y-axis. Okay. Most probably the time is on the x-axis because this is the independent variable. Okay. Most probably it's on the x. But for some reason, if he wants to change it, he will tell you, draw the time on the y-axis and draw the temperature on the x-axis, which would be wrong, but خلاص, that's what he wants. خلاص. You will have to abide by the rules. That's it. Okay. This is for the question of the gradient. Another question for this, okay, for this specific graph, he could tell you, triple I, for example, find the initial value of, okay, find the value of y. Let's say this is the temperature and this is the time, for example. Okay, find the value of the temperature when the time was let's say 5, whatever. Okay, and you don't have one of these points. This point, let's say it's 4, and this point is 6. So 5 would be somewhere in the middle. So how to find the initial, how to find the temperature when the time was 5? You have to just draw a vertical line from 5 until you reach the graph, and then draw a horizontal line and find the value of the temperature from the y-axis. This is one of the questions. Another question. Let me just remove this. Okay, and I will draw the best fit line, which was something like this. Okay, another question. Yes, it would be worth 1 mark. Another question, for example, Ivy, it could ask you, what was the initial temperature based on the points you have drawn? What was the initial temperature? And you do not have the initial temperature. Why? Because the temperature, or because the time here was, for example, at time 1, the temperature was at y1. What was the temperature at time 0? So you need, at this case, you need to extend the graph. You need to extrapolate the graph. Sometimes it's called extrapolation. Okay, you need to extend the graph all the way until it reaches the y-axis, until you find the y-intercept. This y-intercept would be the initial temperature. Okay, this would be the initial temperature. So you need to find the initial temperature by extending the graph extending the line until it reaches the y-axis. Again, there's another really good question. Okay, if you had the rate of cooling, let me draw the graph of the rate of cooling. Okay, a graph of rate of cooling would be definitely inversely proportional. Okay, from this graph, he could tell you, estimate the room temperature. Okay, you could draw the graph worth 4 marks, whatever, and this is the temperature. Okay, this is the temperature in degrees Celsius, and this is the time, okay, in seconds. And from this graph, he could tell you, estimate the room temperature. How can I find the room temperature? The room temperature would be, okay, the room temperature would be near بالظبط, okay, near the end of the graph, would be somewhere here. يعني this temperature of the initial of the water, of the hot water, what happens to the temperature of the water? It keeps on decreasing. Okay, it keeps on decreasing with a decreasing rate of cooling. I know it decreases, the temperature decreases with the decreasing rate of cooling until it reaches the room temperature. So the room temperature, this would be the room temperature would be, okay, the curve keeps on decreasing until it reaches the room temperature. So this would be around the room temperature. He would tell you, estimate the room temperature based on the graph. It would definitely be something less. For example, if this had reached a temperature of, let's say, 25 degrees, so the room temperature would be around 23 degrees. I'm just saying. Okay, yeah, this is for the graphs, some of the more famous graphs that we have in our syllabus. Okay. Um, what else? I hope that answers most of your questions that you have asked. Okay. Okay. Moving back to these points again, I'll go just very quickly. Experimental accuracy. This was one of the more important points. Okay. The experimental accuracy. Need me to repeat the room temperature. Okay, again, room temperature. If I have the rate of cooling, this is a decreasing. Okay, this is decreasing rate of cooling. What's happening? The temperature of the water keeps on decreasing. It will keep on decreasing until it reaches what? Okay, will it keep on decreasing until, for example, it goes into the negative, it becomes negative 20 or negative 30? No, definitely not. What will happen to the temperature of the water? It was 80, 70, it will keep on decreasing until it reaches the room temperature. If I had a hot cup of coffee and I leave it for a couple of hours, okay, this is one of the more famous questions in our tests. Okay, if you had a very hot cup of water and you leave it for a couple of hours, what will happen to the temperature of the water? What will estimate a final temperature for the water? What would the final temperature of the water be? It would be the room temperature. Okay, the question, for example, AI would have a thermometer and you tell you take the reading theta R of the thermometer. Okay, theta R. What is theta R? This is the room temperature. Okay, this would usually be the first question in okay, it would be the first question in this experiment. Okay, theta R, take the reading from the thermometer. Usually, the theta R is in the range of 21 degrees to 24 degrees. It's usually in this range. Okay, so take the reading of the and then by the end of the question, by the end of the experiment, he would tell you estimate a temperature for the hot water. You would say, well, the temperature of the hot water would definitely reach something near the room temperature. If you had an exact room temperature, let's say 23 degrees, then definitely the hot water would reach 23 degrees by the end of a couple of hours. Okay. Okay, I'll talk about the justification. Someone's saying justification, calculating. Yes, justification, you have to use numbers from the table. You must use numbers from the previous table or from the previous experiment that you have conducted. ماشي؟ طيب. Um, whenever I say, are the numbers equal or not? Okay, are the numbers equal or not? I would never give you two numbers which are actually equal. Okay. You'd never have, for example, 20 degrees and 20 degrees. I would never give you those numbers. I'll give you two different numbers, slightly different numbers, 20 and 21. Uh, 150 and 120. Okay. Okay. For example, okay, if you have two very different numbers, okay, if you have two very different numbers, how will I know if they are equal or not? For example, if you have a reading, let's say the reading was 400 centimeters, whatever, okay, or 400 grams. Let's say 400 grams instead of centimeters. The reading was 400 grams. Another student conducts the experiment and the reading was 425 grams. Okay. First student had a reading of 400 grams and the other student had a reading of 425 grams. Are these the same values? Mister, they are very far apart. They should be different. Okay. Mister, they're definitely not the same values. صح? Actually, wrong. Wrong. They are the same value. How are they the same value? How, Mister, they are very far apart. They're 25 grams apart. They have to be different. They're actually not different. They're the same. Why? Because they are within the limits of experimental accuracy. Let's calculate it together. 425 divided by 400. Okay, 425 divided by 400. What would that give? That would be a very small percentage error. Okay, it would give you a really extremely small percentage. That would be 1.0625. 1.06. 1.06. What does 0.06 mean? 0.06 is a 6% accuracy, a 6% difference. Is this acceptable? Yes, it is acceptable. Okay, even though they are 25 grams apart. Okay, 25 grams apart. Are they acceptable? Yes, they are acceptable. Why? Because they are within. But are they the same number? Yes. Okay, agree. Okay, for example, yes, agree, or they are the same. Why are they the same? Let's say that 400 and 425 are very close together, are very close, even though you might think that they are quite far apart, but they are actually very close and within the limits of experimental accuracy, within okay, the limits of experimental accuracy. Experimental accuracy. Why? Because it's less than 10%. So this is definitely within the limits of experimental accuracy. If it's much greater, it would be exceeding the limits of experimental accuracy. And then there's a gray area. There's a gray area between 10% and 15%. Okay, this is more of a gray area. For example, if you had, let's say, 400 grams and the other reading was 450 grams. okay, or 445 grams. For example, okay, these two readings, are they far or are they close? Let's calculate 445 divided by 400. Are they the same or not? 445 divided by 400 would give you a difference of 1.11. This is what 1.11, which means that it is 11%. There's an 11% accuracy, an 11% difference. Is this equal or not? You can say either. You can say yes or you can say no. Both answers would be acceptable. If you say yes, okay, you have to say that they are close and within the limits of experimental accuracy. If you say no, you have to say far and exceeding the limits of experimental. Both answers would be correct in this case, okay? Far and exceeding. Okay, هنا you will say close and within the limits of experimental accuracy. If it's above 15%, it would be definitely no. Yeah, if it is above 15%, definitely it would be exceeding. But I'm talking about this gray area, 11%, 12%, 13%. This is a very gray area. It could be acceptable and could be not. Okay, so if it is within this very gray 12%, 13%, okay, you could consider it to be yes, and you could consider it to be no. Yes, what's your question?
طب يا مستر لو في رقم زي مثلا 2.2
Hmm.
دي كده يعني تبقى 20% ولا 2%؟
2 point, لا you'll never have 2.2. You'll never have 2.2. يعني if you have, for example, 2.2 into you divided the larger number by the smaller number, but if you have two numbers which are very obviously يعني very far apart, what do I mean? For example, if you had, let's say, 3 ohms and the other value was 6 ohms, okay, this is definitely, they are definitely not the same number. Okay, this is twice as large. Okay, this is 100%. There's 100% difference between these two numbers. So this is a definite no without even calculating. You don't even need to calculate. You don't even need to spend time calculating this very huge difference. Okay, 3 ohms, 6 ohms, 9 ohms. لا خلاص, these numbers are very far apart. Okay, you don't even need to waste time calculating. 200%, yes, 200%. 15% exactly, if you have 15% exactly, you can write it down as no. Okay. If you have 15% exactly, it could be written down as no. This is when it comes to the experimental accuracy. This is one of the very, very popular questions in paper 6. Probably you'll never have a paper 6 without this question. Paper 6 will never come without this question. You have to have at least one question asking you, are these numbers the same or are they not the same? Okay. For example, if you calculate two resistors, okay, if I calculate two resistors and the resistance of one of the resistors is, let's say, 4.5 ohms, and the other resistor is, let's say, 4.9 ohms. Okay. Are they the same number or not? Why they look close. They seem to be close. Okay. Only 0.4 difference, 0.4 ohms difference, 0.4 ohms. Are they the same or not? What should I do? Very simply, 4.9 again divided by 4.5 using your calculator. 4.9 divided by 4.5 would give me a reading of 1.09. 09 is what? 9%. 9% is acceptable. Okay, 9% is acceptable. So I will say, are they the same number? Yes. Okay, agree. Okay, they are the same number. Okay, they are, okay, the same. Why are they the same number? Okay, it have 2 points. The statement and the justification, the statement and the explanation. You have to explain why are they the same number? Why are they the same number? I would say because 4.5 and 4.9 are close and, okay, you have to say and within hmm, the limits of experimental accuracy. Okay, limits of you have to say it, of experimental accuracy. Um, okay. You have a question?
هو مستر هو حد كام قول ان هو exceeded the limit of the experimental
Again,
accuracy.
if it's above 15%, definitely it has exceeded the limits of experimental accuracy. If it's above 15%, definitely exceeding the limits of experimental accuracy. Okay? Okay. I hope I have answered all of your questions regarding this point. Okay? طيب. يلا. Some improvements. How can I improve يا شباب؟ احنا we know that there are many improvements in the test. One of the most famous improvements, how to find more accurate results, how to make sure that my results are accurate. I could repeat and take average. I could increase the number of values. For example, if you only tested for two angles, okay, let's say he tested for 30 degrees and 40 degrees. That's it. Is that accurate? No, that would not be accurate. Okay, that would not be. You have to increase the range. How can I increase the range? For example, I would take even more numbers, like 20, 25. We can take 35 and 45. Okay, 50. 50. You have to increase the numbers. You have to increase the experiments. Okay, you cannot conduct the experiment only once or twice. You have to conduct the experiment at least 5 times. That's the whole point of paper six. Paper six, any experiment in the world, you cannot conduct an experiment only one time. You have to conduct the experiment more than once. You have to conduct the experiment several times. Why? To make sure that your numbers are within the limits of experimental accuracy, to make sure that the numbers are reliable, to make sure that you have no anomalies, so that you can ignore any anomalies, because the anomalies would definitely make the experiment wrong. Okay, if you have any anomalies, how can I ignore these anomalies? I can draw a graph. Okay, when you draw the graph, you can see, oh, this number is anomalous, so I can ignore it. You can repeat and take average. Okay, that's why we have to repeat several times, because if you take only one anomalous or this anomalous result, the average would be wrong. Okay? It would be a wrong answer. You have to repeat and take average. Okay, to decrease. Okay, why do we repeat several times? To decrease the percentage of error. Okay, to decrease the percentage of this human error, or percentage of whatever error you have. Okay. Um, Okay, you can, yes, هنا this is the point I'm talking about, the variable errors. Uncertainty, yes, possible causes of uncertainty. For example, if you have a ruler, okay, one cause of uncertainty, you didn't take the reading perpendicularly. You didn't start from zero. You have other, for example, the measuring cylinder, you didn't take the reading from the bottom of the measuring cylinder. You have many problems. You have many solutions to these problems. طب يا مستر, what if I write down a problem, or what if I write down a solution which is not written down in the marking scheme? Am I wrong? لا. Most probably, if it's a logical answer, okay? If it is a logical answer, then it would be right. Okay. If it's a logical answer, then it would be right. If it's an illogical answer, if it has nothing to do with the actual experiment, okay, if you're saying, for example, take the reading perpendicularly from a voltmeter or from an ammeter, hey, that would be definitely wrong. Why? Because we don't take the reading perpendicularly from the voltmeter or the ammeter. The reading is very direct. Okay. These are some of the uh, ways to prevent these uncertainties. Again, how to improve them? Yes, we can repeat and take average. We can increase the range, for example. Okay. خلاص these كده خلاص أنا كده I'm done with this. Oh, yes, apparatuses. I wanted to talk about some of the apparatuses that we will use. Okay, and then I'll go back and check some of the harder questions in the past few years, inshallah. Some of the apparatuses that could be used. Will you be required to memorize all of these apparatuses? No. لا خالص, never. You're not required to memorize them, but it's يعني good practice to just go through them to understand what are the different apparatuses that may be used in the lab. Okay, that may be used in a lab. For example, you have a set square, okay, you have a string, you have a thread. Well, string and thread, they could be considered to be the same. Adhesive tape, we can use tape. Yes, if you want to stick, for example, the mass to the ruler, you can use a tape. Okay, definitely you can use a ruler. You have some scissors if you need them. We won't be needing all of these apparatuses. Okay, these are some of the general apparatuses. Then you have some of the mechanics. Okay, you have the bob. Okay, you have the meter ruler. You have some masses. Okay, G clamp. Do I have to write down all of these? You do not have to. Stopwatch is very. Okay, it's a crucial apparatus. You have to write it down most probably if there is a question asking you for something that has to do with the time. Okay, some thermal physics. Yes, the thermometer. Okay, the beaker, measuring cylinder. Okay, boiling tube. You're not a pivot. I don't need them. I do not need these. Most likely, you will not be required to write them down. Okay. Um, Converging lens and diverging lens. Okay, diverging lens, it's very rare. You will probably never be asked to draw an experiment. But if for some reason, okay, if for some reason he tells you to draw a diverging lens, how do we draw a diverging lens? This is a diverging lens. Okay, it's one of the newer points in paper 6. Okay, it's one of the newer points in paper 6, but this is a diverging lens, okay? And that's it. That's all you need to draw, okay? You will not be required to further explain anything that has to do with a diverging lens. Why? Because diverging lens, that's all you need to do is draw it. In paper 3 or paper 1, you were required to actually know that the lens, okay, as the rays moved parallel, they diverged away from the lens, okay? That's in paper 3 or paper 1. In paper 6, you will not be required to draw these rays. Okay, you will not be required to draw these rays. But again, for the precautions of the lens, they would be the same as the precautions of the converging lens, such as move the lens slowly, or move the object slowly, or move the screen slowly until a clear image appears on the screen. Okay, use a dark room. Um, okay, they would be the same, but again, these are for the diverging lens more than the converging, for the converging lens more than the diverging lens. One point which is quite important, the plane mirror. Okay, one of the difficulties, one of the problems that we face while using the plane mirrors is the thickness, okay? The thickness of the mirror. Okay, if you have a mirror, whenever you have a question and you're measuring the angle of incidence, the angle of reflection, and then points, pins P1, P2, whatever. Okay, one of the problems that may appear, for example, two students measured the angle of incidences and angle of reflections, and they found that their values weren't the same. Why would that be? Because of the thickness of the mirror. The thickness of the mirror could cause a problem. Yes, you have other problems, such as they didn't use thin lines. Okay, one of the precautions, use thin lines. One of the precautions, take or view the bases perpendicular. View the bases of the pins. Okay, you don't say view the bases perpendicular. View the bases of the pins. Make sure that the pins are 90 degrees, or make sure that the pins are perpendicular to the lines. Make sure that you have sufficient distance between the pins. يعني the distance between the pins has to be at least 5 centimeters. Okay, the distance between the pins cannot be 1 or 2 centimeters. That would be wrong. Okay, one of the questions would be that he has pins 1 and 2. Okay, and they are quite close. He would ask you, are they at a suitable distance? You would say no. Why? Because the distance between them is less than 5 centimeters. If the distance is greater than 5 centimeters, then they would be at suitable distance. So 5 or more, 5, 6, 7, 8, whatever, usually up to 15 centimeters. Okay, that's the maximum distance that you can have between two pins. The maximum distance. Again, going back to the optics and the converging lens. Okay, yes, use thin lines. Whenever he says, for example, what is one of the precautions? Okay, use thin lines. One of the precautions in the converging lens. Oh, in the converging lens, or in the images that appear, or in the objects that appear, in the distances, you have distance, let's say u and distance v. For example, distance u was, you measured it from the diagram, and it was 2.5 centimeters. Okay, it was 2.5 centimeters, yes, in the lens. Okay, 2.5 centimeters. For example, if he tells you that this measurement, or these measurements, are all 1/10, okay, 1/10 the actual scale. Okay, 2.5 centimeters is what it is, 1/10 the actual scale. What should I do? What should you do? You should just multiply it by 10. So if the small u is 2.5 centimeters, the capital U would be 25. I just multiplied by 10. Okay, if V was, let's say, 8 centimeters, then the capital V, okay, the actual distance would be 80 centimeters. Okay. Yes, the thickness of the mirror, the thin lines, these are all used in optics. Okay, whenever you have a converging lens, if you have a ray box, if you have a ray trace sheet, okay, you have to use thin lines. You cannot use thick lines. What do I mean by I cannot use thick lines? This is a thin line. This is a thin line I'm drawing. And this would be a thick line. This would be a thick line. This line would be wrong. You have to sharpen your pencils. Actually, one of the answers, sometimes, not all of the times, sometimes you can write down, use sharpened pencils. When you use the sharpened pencil, that would be sometimes, not all of the times, it could be considered to be one of the precautions that you can use in this answer. Okay. Okay. تمام. Okay. Precautions, experiments, light source, precautions, and I said the precautions, خلاص. I said that you don't have many precautions for this experiment. You do not have many. The precautions are use thin lines. Okay, make sure you view the bases of the pins. Okay, make sure that the pins are at a suitable distance. Okay, these are the precautions for this experiment. Okay. If you want to improve, you can repeat and take average. You can make sure that you're using a dark room, for example. These are some of the improvements. Okay. Diverging, sure, he will not ask you about the diverging lens in this experiment, because diverging lens wouldn't actually give a clear image on the screen. It would give a totally different type of image. Okay, it would give a different type of image. Okay. Diverging, converging image. Okay, it would give an image on the screen, and you have to, yes, you have to move the object, or move the screen, or move the lens slowly until a clear image appears on the screen. Type. Moving on to circuits. Okay, circuits is one of the easier questions. Okay, and I really, really hope that you have one of the questions. Okay, in circuits. Why? Because circuits are quite easy. Honestly, circuits are quite easy. All you do is take the reading of the voltmeter, take the reading of the ammeter, measure the resistance, R equals V over I. You can repeat it once or twice, and then he would ask you, are these numbers equal? And then he would tell you, Wallahi, I need to okay, he would then tell you, I need to, for example, draw another circuit with with two resistors in parallel, or with three resistors in parallel. I need to draw a voltmeter. I need to draw an ammeter. Okay, use let's say a variable resistor. Well, it's okay. It's okay. We can draw all of these components. Okay. That's it. That's it for most of these points. As for the ray trace sheet, okay, let me open one of the tests, one of the past papers, okay, that had a ray trace sheet. Let's, for example, open up June 23 variant 1. Okay, I do not remember if it had a ray trace sheet or not, but let me check it. Okay. So this is paper 6 variant 1. This is the solution. Okay. Again, this is one of the graphs. So he said the best fit line. He said best fit line, but the graph had to be a curve. For this question, it was a best fit. Line, he said, draw the best fit line, but the answer was a curve. So he does not have to say that the answer is, or draw the best fit curve. He said best fit line, and the answer was a curve. Okay, so it's not wrong. Again, for example, theta R. Oh, I'm always telling you, theta R is the room temperature, so you have to take the reading of the room temperature. Again, rate of cooling is decreasing. You have to use the unit of the rate of cooling, decrease Celsius per second. Okay. Um, ray trace sheet. Okay. What do we do in the ray trace sheet? شباب, while solving this question, actually, this is one of the easier questions. Why? I'm telling you, paper six is easy. Okay, and whenever I find a question, I'm telling you this is one of the easier questions. This is one of the easier questions. Does that mean that the whole paper is easy? Like, it's kind of easy. It's not hard. Paper six is not hard, but all you have to do is just read the questions carefully. Okay. Honestly, this question, for example, all you have to do in this question is read very slowly. You have to read all, okay, all of the points stated. Okay, you have to read all of the points stated. Yeah. What's your question?
مستر، أنا الحاجة الوحيدة اللي أنا بتلخبط فيها هنا أنا بحط البرجل فين؟ كان البرجل اللي أنا بحطه فين؟
Okay, the protractor. Okay, how do you position the protractor? For example, let me read quickly through the question. On figure 3.1, draw a normal. Because I drew a normal through the center of AB. You have to measure the distance between A and B, and you have to draw a normal between them. You have to draw a normal between A and B and place and draw the normal above and below the above and below the line. He said, continue the line so that it passes through the curved side of the block. Class, I will continue the normal below the curved side of the block. Label the normal and L. You have to write down an L. Label the point C where the normal crosses AB. خلاص I labeled point C where it crosses AB. That was easy. The other easy question as well. Draw a line DC. Okay, you have to read it very carefully. Draw a line DC below line PC. Where is PC? How's this PC? Draw a line DC below a PC. Where's PC? Mister, we don't have PC. No, you have PC. This is P and this is C, the point which you had just drawn. You will need to draw a line DC below the line at an angle of 30 degrees to the normal. What do I mean by to the normal? 30 degrees to the normal and to the left of the normal. How will I draw a line 30 degrees to the normal and to the left of the normal this way? Okay, I will place my protractor. My protractor will be positioned this way. And the center of the protractor will be here. And then the 0, I will count 0, 10, 20, 30. Okay, so for example, this is 30. I will put a small dash and then draw the line. And then draw the line. طبعا using, of course, الشباب using a ruler. Please do not even think about drawing the line without the ruler. Don't even think about it. Okay, you have to draw the line using a ruler. Again, read it very carefully, very slowly. Read this. Okay, point again, a line. DC. I drew the line and I didn't I didn't put the point D. Would that be wrong? It would be wrong. You have to put the point A, D. Yes, sir, all of this is worth 1 mark. Yes, it's worth 1 mark because it's very easy. It's very trivial. What are you doing? You're doing nothing. You're literally drawing a line with an angle. That's it. You just need to make sure that this line is with an angle of 30 degrees to the normal. To the normal. Not, شباب, not to the barrier. It's at an angle of 30 degrees to the normal. To the left of the normal, not to the right of the normal. Below. Okay? Below the line, and then we need to extend the line a little. Why will we extend the line a little? Because we will put points D, we'll put pins P1 and P2 on the line. You have to label them in pen. No, you don't have to label them in pen. Okay, don't have to label them. You can label them in pencil. It would be okay. Okay, now I drew the points P1 and P2 on the line. Yes, P1, P2. And the distance between P1 and P2, it has to be greater than 5 centimeters. The distance between the 2 points must be greater than 5 centimeters. If it's less than 5 centimeters, it would be wrong. Okay? it would be definitely wrong. The distance between P1 and P2, between any 2 points on, the distance between P3 and P4, if you measure the distance between P3 and P4 in this question, it would be 5 centimeters or greater than 5 centimeters. Okay, that's why you have to measure the distance. You have to make sure that the 2 pins are as far as possible, as far as possible. Okay, don't draw them close together at all, please. ماشي. Okay, and then he will tell you again. He keeps on telling you what to do. He keeps on telling you what to do. Now I have positions pin 3 and P4. Okay, I draw a line through the positions of P3 and P4. Continue the line to AB. Draw or label E at the end of the line furthest from AB. Very simply, what should you do? Just draw a line from P3 and P4. Okay, continue the line until it reaches point C. It will reach point C. And then at the opposite end of this line, you have to label it E, so that this line would be called a EC. Plus, this line now has a name. It's called EC. The other line, it's called DC. You have 2 lines, DC and EC. Okay, I drew the line, and I labeled it E. ماشي. And then he told me to measure the angle theta, angle alpha, between إيه بقى؟ Between NL and CE. Between NL and CE. Angle between NL and CE. NL and CE. So I need to measure this angle. Okay, again, I will take my protractor and put it on the other side this way. This would be the center of the protractor, but this time I'll start the 0 from this side. Do not start the 0 from the opposite side. Why? Because that would be an let me remove this line again. Okay, if you draw the line, okay, this is the protractor again. This is my protractor. Okay, it started off from 0. 0, 10, 20, 30, 40. Okay, it would reach around 50, I guess. Okay, if you measure the angle from here, 0, 20, 90, okay, 110, 120, okay, it would be definitely wrong. So you have to measure the acute angle. And he stated it very clearly. Measure the acute angle, which would be an angle less than 90 degrees, okay? He doesn't have to actually say that it has to be an acute angle. He doesn't have to say that. But usually we measure angles which are less than 90 degrees. Okay, he doesn't have to say it, but we usually measure angles which are less than 90 degrees. Okay, خلاص, the angle was 49. Oh, one precaution. You have to use thin lines. One precaution, you have to use thin lines. Okay, again, you can draw the شباب, لا, whenever he says measure the angle, measure an acute angle. Okay, never measure an obtuse angle. Never do that. Measure an acute angle. Whenever he tells you measure an angle, measure always an acute angle. Okay, that's for the angles, for measuring the angles. Again, the question هنا, he told you to measure angle beta. Okay, angle beta was between AB and CF. خلاص, I measured the angle. It would have been 72. Okay, are alpha and theta equal? Theta was 18 and alpha was 49. Definitely not equal. I don't even need to calculate it for this question. For this question, you do not even need to calculate it. Why? Because they're very far away. 49 is more than twice. Okay, more than twice 18. It's more than 100%. خلاص, definitely it's wrong. Definitely. يبقى 18 and 49 are definitely far apart. They are definitely exceeding the limits of experimental accuracy. Okay. Again, for planning an experiment, the most important thing to read in this question is what? Plan an experiment. Plan an experiment to investigate what the change in resistance of the filament lamp when the current is increased. What will I measure? Again, what will you measure? You will measure the change in resistance. When you measure the change in resistance, this is the dependent This is the dependent variable. When the current is increased, this is the thing that you are controlling. This is the thing that you are changing. So this is the independent variable. Okay? Independent variable. The current is the independent variable. This is the thing that you are changing. For this question, the range of values would be what? Would be the current that you are changing. The current, for example, 1, 2, 3, 4, 5 amperes, the independent variable. Okay. And then depending on the value of the current, you will measure the resistance. You have to use the rule. You have to use the equation R equals V over I. Therefore, you will have a voltmeter as well. Okay, you must have a voltmeter as well. Oh, he told me draw a diagram. You have to draw the diagram with a voltmeter and a meter. A variable resistor, you could use the variable resistor. Why? Because the variable resistor, what would it do? It would control the current. This is the use of a variable. What does it do? It controls the current. خلاص يبقى I drew the variable resistor, the voltmeter, the ammeter, the lamp, okay, a switch if you want, a battery, a power source, whatever. This is a very, very nice diagram. Okay, how would you conduct the experiment? How would you do the investigation? Okay, for each current. Okay, oh, yani you can change the variable resistor. Okay, until you reach a certain current, and for each current, measure the or take the reading of the voltage on the lamp. Okay, and then calculate resistance R equals V over I. R equals V for each. Okay, I'm sorry. Take the reading of the voltage from the voltmeter, take the reading of the current from the ammeter, and then measure R equals V over I. Record the readings in the table. And then what should I do? You have to repeat the experiment for all the different values of I, for all the different values of the current. You have to say that. If you do not say that, that would be wrong. Okay, شباب? So you must say that in the explanation. Okay, for this table, what are the requirements? What are the columns you need for this table? You could add the current in ammeters. You could add the voltage in volts, and you could add you have to add the resistance in ohms. Okay. Oh, this is the table. Okay. For this question, it was such an easy question. Honestly, I really hope that you have an easy question like this one. Okay. It's a really, really trivial and easy question. Okay. Um, why should you draw a variable resistor in this question? Because the variable resistor in this question controls the current. And in this question, you actually need to what? You need to change the current. So how will you be able to change the current if you do not have a variable resistor? But using the variable resistor, you will be able to control the current. And when you control the current, you can measure the new resistance of the lamp or whatever happens in the lamp. Okay. شباب, one of the take the reading perpendicularly from the thermometer. No, in this question, there is no thermometer. Okay, there is no thermometer in this question. You will not take the reading. You cannot say that as one of the precautions or whatever. Okay, for other questions, if you have another question with the thermometer, yes, you can say take the reading thermometer. Can I use different number of cells for this question? A different number of cells. It could give you, yes, it could give you a different current. But it's more accurate, honestly, to be very honest. It would be very more accurate to use a variable resistor. Okay. This is yani, very, very honestly. Um, for this question, there was something I just one of the precautions again. Yes, one of the precautions you had to say if he asked you to write one of the precautions, okay, one of the main precautions with any circuit would be switch off the circuit, switch off the circuit between each reading. Why? Oh, between each reading. Why? Because as you leave the circuit for a longer time, what happens? The temperature rises. And when the temperature rises, what happens to the resistance? The resistance increases. So look, when the temperature rises, the resistance increases. When the resistance increases, the voltage increases and when the voltage increases, the lamp would be brighter. Okay, the brightness of the lamp would also increase. So that's why for this question, for example, it would be logical, okay, if he asked you to write one of the precautions, okay, it would be logical to write down switch off the circuit for each between each reading. Why? Because when you switch off the circuit, you will give the time the lamp some time to cool down. Okay, when it starts to cool down, it will return back to its original resistance and its original temperature, so it would give off the same voltage and the same brightness. But if the lamp was too hot, if the filament lamp gets too hot, the temperature rises and the resistance increases, the voltage increases, and the lamp will be a lot brighter. Okay, is the resistance and current inversely proportional? Yes, the resistance and current are inversely proportional. As you increase the resistance, the current decreases. Okay, as for the values of the current, yes, you have to write down the values. If you want to, you can write down the values of the current. Oh, I wrote them down. You can write them down. 1 amperes, 2, 3, 4, and 5 amperes. You should have written them down as the range of values, okay? For some reason, I didn't write the range of values in this question. Usually, I do write them down. Okay, what else? Take the reading when the ammeter is 0. You can say, yes, check 0 reading on the ammeter. Make sure that the reading, that the ammeter is set to 0. Yes, make sure that the reading is set to 0. Variables of the material of the filament lamp and tungsten. لا, he will not ask you about the variable, the material of the filament lamp. Okay, we know that the filament lamp, he will not ask you about the material of the filament lamp. Okay, that's not even one of the one of the let's say controlled variables. The control, it is the same lamp. You just use the same lamp. If you are changing the diameter of the, let's say, the wire outside, if you have a resistance wire, if you're changing the resistance wire, if you're changing the diameter, then one of the constants has to be, one of the controlled variables has to be the diameter, the material of the wire. Okay, can I say voltmeters and ammeters are 0? Yes, you have to say that they are set to 0, that the readings on the voltmeter and the ammeter are 0. Ammeter set to 0, it's just a simple, like if you have a stopwatch, okay? Stopwatch, if you use it and forget to reset it, it would have a previous reading. The same applies for the ammeter and the voltmeter. Sometimes, not all of the times. Sometimes the voltmeters and ammeters are faulty. Sometimes they could have a very small reading, okay? When you switch them on, they could have a very small reading, 0.01 or 0.1, okay? They could have a small reading. So you need to adjust it and make sure that it has a 0 initial reading, that it is reset to 0, okay? Okay, what else? Planning's paragraph, again, I said that you can write it down as a paragraph or you can write it down as points. Okay, in this question he didn't say yes, and for this question specifically he did not say you need to write down any precautions. He didn't need you to write down any controlled variables. He didn't need you to write down any apparatuses, which was very weird. Honestly, this was very weird for this question. That's why it was suspiciously easy. This question was suspiciously easy. Okay, usually we are required to write down the apparatus and the controlled variables. Okay, but for this question, it was suspiciously easy. Why? Because the diagram in this question was worth at least 2 marks. Okay, this diagram was worth at least 2 marks, and that's why he couldn't give you any extra points. Okay, the maximum grade for this question is always 7 marks, and that's why he cannot give you anything extra to do in this question. Okay, temperature increase resistance. يا جماعة يا حبايبي يا جماعة. When the temperature increases, the resistance decreases in the thermistor. I swear, wallah, it's in the thermistor, not in the not in the filament lamp. When in the filament lamp, when you increase the temperature, the resistance increases and the voltage increases and the brightness of the lamp increases. what you are talking about is the thermistor. Please do not, okay, يعني mix them up. Please do not mix them up. A lamp gets hot after some time. When it gets hot, the resistance increases and the voltage increases. Okay. That's it for this test. Let me check another test. There was another March 23. It was also interesting. Okay. March 23. Okay. Was quite interesting. Okay. هنا if we go quickly through the points, okay. For example, why is it more accurate when using a meter ruler to measure the distance for 5 marbles instead of 1 marble? Okay, can you measure the distance of 1 marble? Yes, I can measure the distance for 1 marble, but it's more accurate to measure the distance for 5 marbles. Why? Because the percentage of error would decrease. There is a percentage of error. Okay, a percentage of error is because you cannot measure very, very small distances. Okay, using the ruler. For example, like measuring the thickness of a sheet of paper. You can never measure thickness of one paper alone. Now you have to measure the thickness of 100 or 200 sheets of paper. Same applies for these marbles. You cannot measure the distance of one marble alone. You have to measure the distance of several marbles so that the percentage of error would also decrease. Again, how to actually measure the distance of the marble, we use the wooden blocks, and this is one of the more popular questions, okay? It's a very popular question, how to measure the distance, how to measure the diameter of a marble, how to measure the diameter of a sphere, okay? Whatever, using 2 wooden blocks, you push in the 2 wooden blocks, okay? You have to have the marble in the middle, and you measure the distance between the 2 edges of the blocks. Okay? Okay, this was quite easy. Measuring, taking the reading from the bottom of the meniscus. This is a measuring cylinder. You have to take the reading from the bottom of the meniscus. Again, very simply. Okay, this is all quite easy. This is the room temperature again. Okay, again, you have to say rate of cooling also decreases. Okay, this are very simple. We all know these questions. We all know these 2 variables that had to be constant. The volume of the water has to be constant. The room temperature has to also be constant. Okay. Again, we have a circuit crocodile. Okay, one of the problems that may appear while using the crocodile, okay, one of the difficulties that may appear while using the crocodile was that they didn't actually measure the distance very accurately. Okay, when he placed the crocodile on one end, he didn't measure the distance very accurately. So this is one of the problems, one of the difficulties that you may face if you have a crocodile clip. Okay. That's why, for example, if 2 students measured the resistance, they could have different results. And again, planning and investigation, you would have, okay, you should write down any apparatuses, write down the key variables. Okay, this was an easy exam, to be very honest. Okay, you had to write down the method, the table. It was quite easy. Okay, the range, what was the range in this question? The range was the distance between when the ball left, okay, the channel and until it reached the ground. This was the range of the ball in the air. I guess we've gone through most of the hard questions. Let me just open up one last exam, okay, and we will be done, inshallah. Okay, how do you know the range of values? Okay, type another question. How do you know the range of values? The range of values is the independent variable. Plan an experiment which will enable him to investigate how the range of the ball depends. So this is the dependent variable. How does the range of the ball depend on what? On the angle at which it is launched. The angle is now the independent variable. It is the range of values. So how can you write down some suitable independent variables? For example, an angle would be 5 degrees, 10, 15, 20, 25 degrees. Okay, don't go jumping مثلا from 20 to 40 to 60 to 80 to 90. That would be wrong. Actually, the maximum angle would be 90. Well, 90 would be wrong. If you write down 90, it would be wrong. Why? Because if the angle okay, if this variable angle is 90 degrees, it would stop the ball from actually ever leaving the channel. So you can increase the angles up to 80 degrees, for example. Still, that would be very difficult for the ball to actually leave the channel. The variables, the independent variable, okay, these are the range of values for this, for any question, planning an experiment. The range of values are what are the independent variable. Error crocodile clip. Okay, again, a crocodile clip. Very quickly, crocodile clip. You place the crocodile clip at a distance L. If you want to increase or decrease the distance L, you'll just simply move the crocodile clip and measure the distance. There could be an error. No, I'm just stating there might be an error in measuring the distance between the ends, okay, of the crocodile clips. For example, there might be an error while measuring the distance between the crocodile clips. So that's the point, that while taking the measurement, while taking the reading from the ruler, okay, you could, for example, add or يعني subtract. There would be يا شباب, there would be an error. So that's the problem while measuring, okay, the distance using a crocodile clip. Other than that, you wouldn't have this problem. Why? Because you can take the reading perpendicularly from the ruler. It would be quite easy. Okay. I need to open up one last exam, مثلا November 21. Okay, November 21. Variant 1 as well. Okay. Okay. Balancing. Okay, if you have a balancing ruler, okay, you need to measure some distances A and B. Okay, one of the questions, you have to draw a graph, for example. Okay, state one practical reason. Okay, one practical reason. Why is it difficult to obtain accurate readings? Why is it difficult to obtain accurate readings for A and B? Because it is actually difficult for us to initially balance the ruler. If you have a ruler on a pivot, it would be difficult to balance this ruler. It would be even more difficult if you add some masses on either side of the ruler. Okay, it would be more difficult if you add masses on either side. So there is an error, okay, or there is some difficulty in actually balancing the ruler on the pivot. Okay, what's your question?
Mr. لو قال لي technique for ensuring that the ruler is as near as possible to being balanced.
Technique. Okay, move the ruler, okay, slowly to the left and to the right. That's all you need to do. You just need to move the ruler slowly to the left and to the right until the ruler balances, or until the ruler tips to the opposite side. So if the ruler tips to one side or tips to the other, it could be now balanced. Okay, that's it. You need to move the ruler slowly to the left or to the right until it tips to the opposite side. ماشي. Yes, it's written down in F. um a question.
مستر هو لما يقول لي مثلا لو عايز يخلي البلوك مثلا 90 سنتيمتر ويخليها بالانسد،
مم.
اقول له اللي هو measure the distance in front and on the back of the block and take the average.
You can measure, yes, the distance, or you can take the average of the readings before and after. Okay, you can take the average of the readings before and after the block. But that's it.
تمام.
Okay, if the block is too large, مثلا, and you cannot pinpoint the actual position on the ruler, you can take the average of the readings before and after the block. ماشي. Moving on quickly عشان احنا we're almost done. خلاص, again we have a circuit. Okay, the circuit would be quite easily. We have another experiment with the lens. Okay, distances. There was a question هنا. Okay, so just how you would continue using the same apparatuses. How would I continue using the same apparatuses? Repeat the experiment, but with more values for you. In this experiment, we had only 30 and 20. So 20, These were the only values for you. Is this sufficient? No, it's never sufficient. You have to use more values. For example, I used 40, 50, 60, 70, and 80. You have to increase the numbers. You have to increase the values of the independent variable for the question. Okay. And the last question, planning an experiment. Okay. Shows the setup. Okay. This is the power. Okay, of the heater was constant for this question, because a lot of you told me that, Mr. Now we can change the power of the heater for this question. Can you change? No, you cannot change the power of the heater. But the question was asking you to plan an experiment to investigate how one factor affects the time taken for the water to evaporate. One factor, okay? Can I change it? No, you cannot change the power. Why? Because the power is constant. What are the other factors? You have many other factors at which the time taken for the water to completely evaporate. The volume of the water, yes, it could be right. The distance between the heater and the water could be right. Someone could say, for example, the surface area of the dish, okay, could be okay. So you have many variables that could be applicable. Okay, you have many factors that you could change for this experiment. You have to choose only one, and all of the other variables would be constant. Okay, that's it. Okay, you need to, for example, I changed the distance. I changed the distance. You could change the volume. You could change other factors for this question. Okay. Yeah, that's it. That's it. Do you have any other questions related to paper 6 or any other uh anything anything that you don't understand مثلا hmm. Okay, we're done. I'm done. بس I'm waiting for any of your questions. If you have any questions, please do ask. Okay. Okay, so you have a question?
هو بيبقى فيه ساعات experiments عن اللينس، يعني بيسأل حاجة ليها علاقة باللينس.
Yes. ممكن you could have the same experiment اهو. This lens experiment. Okay, you could have فين اللينس. You could have this experiment in the you mean the planning experiment, صح? Okay, while planning an experiment, you can have this question. Okay, plan an experiment, for example, to determine whether the thickness of the lens would affect the focal length or the principal focus of the lens. He will give you the equation for the focal length, and you will need to change, for example, the thickness of the lens. How would you actually measure the thickness of the lens? You would use two wooden blocks to measure the thickness of the lens, okay? And that's it. And then you repeat the experiment for all the different thicknesses of the lens. ماشي. Okay. What's your question?
بس لو ممكن في اي حلقه يكون من يعني مثلا في اي سؤال اكسبيرمنت يكون قايل لي ارسم تيبل ويكون هو مديني ريدنجز، او يكون مش مديني ريدنجز ويقول لي اختار عنها تيبل بريدنجز.
Planning experiment, he will tell you to draw a table. He will not provide you with any readings, and you do not write down any readings inside the table. In the table, all you do is write down the table headings, the column headings. خلاص. All of the readings, the range of values, you just write down the range of values initially before the table. You do not write down any numbers in the table. Okay,
اه
that's it. تمام. Any other questions? Okay. Yes, the maximum limit is 15%. March, yes, that was the recording. Yes. Code, new code. لا, no. مفيش. تمام. Okay.